हमारे अक्लमंद लोग हैं जो माशाल्लाह इस मुल्क को इनहेरिट कर रहे हैं, वो माशाल्लाह इस मुल्क को चलाएंगे, बड़ी अच्छी बात है। पर वो इस बात पर बात नहीं करेंगे कि एनर्जी कंजर्वेशन क्या है। इट टुक ब्रिगेडियर साहब टू डू दिस डिस्कशन। ब्रिगेडियर साहब, सॉरी जी, old age is a crime in this country.
No.
Young people who mashallah draw their salaries without any purpose, they are the winners. So Brigadier Saab, over to you.
Thank you very much, Dr. Nadeem. It's a great honor, and thank you for the opportunity and the audience for being here today. This is somewhat quite different perspective that I'll be sharing, and it's a kind of my own thoughts on this subject. I'm not a technical civil engineer architect, so it would be more like a user or a home resident's perspective. So I was doing this kind of a thing, trying to understand why our houses are not energy efficient and why the construction cost has gone to a level where a middle income person cannot build a house with all his savings. It shouldn't be like that. And then I came across LUMS, Dr. Fiaz, I must mention about him, and he is heading the Energy Institute. And that is where the house where I was looking at the consumption, energy consumption for a prospective resident, I actually developed an understanding and what's the crisis at the national level. So it started making more sense. And now I'm working as part of a team at the LUMS Energy Institute, and we are trying to pull together something that I'm going to share with you. So hold on, it will be a brief presentation, but I'm sure it will be different, but nevertheless interesting and simple. So I'll start here with this. It's an interesting slide which shows the base load and the summer peak load this year. And the difference is between about 20,000, around 8 to 12,000 is our base load, whereas the summer peak load this year touched 30,000. So there is a gap of 20,000 megawatt, and it's going to grow with the passage of time because of the trends that we see in the housing industry. Now, this additional 20,000 forces the government to kick in the most expensive generations, where they're generating electricity at the rate of about 80 to 90 rupees and have to sell it about half the price, so losing about 40 to 50 rupees per kilowatt hour on this. It also results into high tariff and capacity charges because you have to keep this capacity and then circulate that on all that thing which is coming in. Now, that is to start point. And interestingly, once I started looking around, it was very interesting for me to see that the US in the past 8 years has actually reduced the peak load by 9,000 megawatt, whereas Pakistan is set to increase the peak load by another 4,000 megawatt in the next 5 years. And that entails an investment of about $100 billion, which we don't have. So what we have, if it is not bad, the worst is going to come. And that is something which is troublesome, obviously for the economists and for other things, but also for the housing. Now, why I am focusing on the housing? Because Pakistan happens to be the only country in the world where our residential or domestic load is far in excess of the other categories like industrial load. As you can see here, blue USA shows 22% of the entire electricity going to the domestic sector, India 24%, and Pakistan is 47%. Now compare it with the same figures with the industrial load, and you'll find that we are consuming about 27% on the industry and 47% on the domestic load. And this is a very unique situation, which is, I think, only in Pakistan. I looked at the data of the about 45 years of EU, and here you can find consecutively the red bars are industry, which is almost more than the twice of the residential and the other areas. So we have this issue where kind of a non-productive energy consumption, which is not adding to the GDP, but only going to the people, and the tariffs going up. So all this crisis is becoming, I think, primarily because of the consumption, which is in the wrong side of the equation. Now, looking a little deeper, this is how our construction materials are. And here you find that those in the red are the construction material we have use. And they also happen to be the heaviest in weight. And that adds to one side of the problem. Next is the thermal conductivity. And here again, our construction material actually are the one which accumulate most energy. So that means without insulation, our homes are bound to be warmer during summers and cooler during winters, as we are experiencing all over. So this is one of the reasons that energy consumption in our domestic sector is far more than the other areas. The problem with the domestic sector is that in summers, the demand rises very high, whereas in all other sectors like industry and agriculture and other things, it's a constant demand. But this is where you have to build the extra capacity, which causes all the problem. Now, let's take it further. Again, the construction material we are using, cement, steel, and bricks, they consume about 82% of the embodied energy, besides being having thermal conductivity. And along with that, if you look at the cost structure of the gray structure costing, 82% of the cost again goes to the same three elements: cement, steel, and bricks, which leads to the extra labor cost. And so we can conclude from here that the energy consumption in the domestic sector can be attributed to the construction material, which leads to the extra high labor cost. And if we are able to look into this construction material, I think the problems will start, will be getting into the solutions. Now, incidentally, I look at it that we have one of the best opportunities. We have, our environment is very favorable. We have very moderate climate. We have abundant of solar energy, something like 325 days in a year. Geothermal energy, I'm going to talk a little later, but that is one of the, Pakistan happens to be one of the most gifted, blessed country, which we are not using. And we do use very superior construction materials compared to what the West is using. They just put timber and some cement boards and put some insulation, and that is their house. We, on the other hand, use the experience, the material which only the billionaires can afford in the West, but here we use it plentiful. So we are with a superior construction material. What we are getting is very high energy consumption and very high construction cost. So it doesn't make sense on both the accounts. Incidentally, I feel if we take advantage of the environment that we have and the other things, we are in an ideal position to actually design some of the most efficient construction models here in Pakistan. And that is what we are going to try and come out today. In this, we have to take advantage of the climate, the availability of the solar energy, geothermal energy that is right here, and also the local material that we are using. And let's try and move towards that area. Now, first of all, I am looking at what we can do with the traditional construction material and with the existing buildings, which are made of bricks, mortars, and cement and steel. I feel because of the very high thermal conductivity and the embodied energy that goes into it, if we just put an insulation envelope around this building, we can eliminate the impact of the weather, which actually affects the building, and you end up very warm homes during summers and cold during winters. And the classic example is of the upper story of all our houses, which with the RCC roof, it's unbearable. Even at 2 o'clock at night, it's not comfortable. And obviously, the energy consumption is very high and the comfort is not there. But imagine if there was an insulated envelope around the building, this very energy, the embodied energy and the thermal conductivity would have helped you, as we are trying to do here. So it is perfectly possible for us during daytime to use solar energy to drive 1 or 2 blowers, push the air I'm not talking of water, push the air below the surface and then get a temperature differential of about 15 degrees plus. And all this is running on the solar. And once this energy goes into the building, it gets stored into the thermal mass that we build in. And that will be, I think, last you for the night also. So that is how we are going to articulate this arrangement that I'm going to be talking today. The second proposition I have is actually adopting passive house standards, which envisages more than 90% energy efficiency. And if we use along with it some light construction panels and use RCC slab for the storage of this energy, so we will end up in a arrangement where probably we should be able to have centrally air conditioned and centrally heated buildings at zero cost of energy. So that is perfectly, I think it's possible. We are working on it, and probably, hopefully, in a few months' time, we'll start with some prototype in which we are going to test it together. So this will be during daytime, you're using solar and geothermal energy. And this energy is also being stored in the RCC floors, which are in the building. And at night time, that stabilizes your house inside the rooms. And the construction time also is drastically reduces, which affects the labor cost, and obviously the cost impact is also there. Now, I'll just, for illustration, flash some of the construction materials which are available. Most of them are available in Pakistan. Some are not there, but they again are cost effective and they can be brought in if we are moving in this direction. Now, the first is the simplest, which actually started being manufactured in Pakistan, but somehow or the other it hasn't taken off. This is interlocking bricks and blocks. Now, you do not need the plaster and the cement actually for the bonding purposes. And you can just place one brick and the next brick and gets locked. It has a very good joint. And the laying time is about 14 to 15 times faster. The cost is less, and a very neat finish can be obtained from this. Boring company is championing it. Elon Musk thinks that by selling these bricks at 1/5 the cost of the normal bricks in the USA, he can recover the drilling cost through this particular method. मिल जाती है सर इसके अंदर ग्रूव्स और वो लगे होते हैं, so they lock to each other. सर होल जो होते हैं लॉक करने के लिए होते हैं ना, also you can run your utilities through that. Electric and all those connections can be done through that. So there are quite a few places. I'll let you know. There in Lahore, there is a very modern plant being set up by one of the bigger industrial group, and also there are some other at the local level. Structured insulated panels. Luckily, there are quite a few, about half a dozen manufacturers in Pakistan. And these are the sandwich panels, which have insulation inside and the core, and then the boards are on the both sides. It could be cement board, it could be finished cladding or paneling, whatever it is. And I think the most relevant example is right here in left-hand sector in Islamabad, where an 11-story building is near completion, and they are using EPS panels for the internal partitions. And the effect was, this was an afterthought, but once they started doing it, the weight reduction was so much that CDA ended up allowing them 3 additional floors, which is 72 additional apartments, each apartment about 50 to 60 million. So that is the kind of advantage these people are getting. And it's really something, I think a good initiative is coming. Now, next I'm coming to magnesium oxide or magnesium oxide sulfate boards and panels. This is one of the best construction material. And incidentally, Pakistan does have sufficient magnesium if we want to get into it. And this could save a lot of weight in the construction. It provides very high insulation. It is practically fireproof. And saving in the cement and labor cost is also very appreciable. Glass fiber reinforced panels. We all know that Pakistan has abundance of, glass fiber reinforced gypsum panels. We have abundance of gypsum in Pakistan. So this very technology was discovered some about 20-25 years, and the patent holder happens to be a Pakistani scientist in Georgia. So he offered this technology free of cost to the government. Nobody showed any interest. He ended up doing this in India. And India today is actually benefiting a lot from this. And the picture you find on the screen is also from one of the Indian projects where you find a 4-story apartment block and these panels being erected. There's a huge saving in cost, huge saving. It's a better insulation. It's very, very speedy, and the finish is also much better than that. Especially for the high rise, this is one of the best material. We have a lot of gypsum, but we are wasting it. And this is one area. In fact, I talked to him, Dr. Shahid Qureshi, and he suggested that it was 20 years back, it was the right decision. But today, if you want to go for the panels, then go for the magnesium oxide boards and panels. So we can leapfrog to the magnesium oxide, but also we can use gypsum productively, far more productively than we are doing today. Another illustration here is of the glass fiber reinforced polymer rebars. India is going leap and bound ahead on this thing. And the reasons are that it has about 80 to 100 years non-corrosive life, 4 times lighter than the steel rebars and 2 times tensile strength than the steel bar. So it's a product of choice. Investment is also very less, and it can be, I think, some of the things that should be coming to Pakistan sooner than later, especially considering that the steel industry, the kind of situation we have in Pakistan. Now, with this brief introduction, I'll be moving to the cost and some of the parameters that affect it. We see here saving in steel, cement, bricks, and labor, which reduces the overall weight of the structure and also the cost. Plus, it does end up providing comfortable and affordable living and low because of the low energy bills. And this was one area in which I've been working as a member of the team that I mentioned at LUMS. And this is a very balanced team of 10 professional people from all the concerned life field. And I think in about a week and 10 days, we'll be finalizing the technical options and plans, and hopefully in moving forward to building 1 or 2 houses on this. Now, I would just like to talk in terms of energy efficiency and the cost, the passive house, which I mentioned earlier. And you can see here, the energy consumption in a passive house is 15 kilowatt per meter square per annum, compared to modern houses, which is 10 times more. And a leaky house, which is Victorian age houses, is 20 times more. So 5% of that. And these are the figures which pertain to UK research. Now, if I was to compare with Pakistan, not only that we have leaky homes, we also have uninsulated homes. So if we just multiply it by a factor of 10, I think that will be very safest debate, and to show that how energy efficient our buildings and constructions are, and how much we need to do to move forward onto this. This is another area I would like to draw your attention. And
concrete has this unique characteristic of thermal mass. It has a very high specific heat capacity, and also the required thermal conductance required to moderate the indoor temperature requirements in our buildings. What we've found is that using life cycle analysis, we've been able to determine that concrete, with its thermal mass properties, is able to generate significant energy savings over conventional construction, in the order of 70% energy reductions for the service life energy use in our structures, utilizing the thermal mass concept. Too many times we focus our attention on the initial embodied energy that goes into putting a structure in the ground, when in fact, in the vast majority of cases, this represents less than 10% of the total energy that will be consumed by that structure over its 60-year service life. The characteristic of concrete is that when you couple it with geothermal energy sources, which is energy available immediately below our feet in the crust of the earth, we are able to temper the fossil fuel energy demand in heating and cooling our structures to the point where we can develop 70% energy savings in our concrete structures.
Now, if you look at this tag on the right side, which shows the temperature which we have in Pakistan in 4 different locations, 12 to 15 feet below the surface. These are the ideal temperatures you would like to have inside the room. And this is only 12, 15 feet down. Now, this very temperature in Chicago is at about 2,500 feet. And likewise, in the West, nowhere it is less than 2,000 feet. And for that, they have to drill, which is very heavy cost. And then they have to pump water because the air is not efficient. And then for lifting water 2,000 or 3,000 feet up, it's a huge cost, and then circulating and managing it. We don't have anything else. We can go to waterless, geothermal, heating and cooling. And this is one of the best places in Pakistan. The cumulative, I think, production of 10 top geothermal energy players in the world is about 13,000 megawatt. Pakistan has a potential of more than 100,000 megawatt. So that is where I am trying to say that if we can combine solar energy with the geothermal energy, and we have a structure which preserves the temperature inside, we can actually have a very comfortable living at zero cost for heating and cooling. Now, let's try to move into that. And that is how I like to explain here. We have to start with the airtight insulated room or a building. So that is the start point. If it is not, it is a leaky and it's not insulated, obviously we'll have cooler homes during summer, winters, and warmer homes during summers, as we are seeing today. What you need here basically is put a small solar panel, about maybe 4 or 5 megawatt of kilowatt per hour capacity. It is needed to drive 2 or 3 blowers, about 500 watts each. They will pull the ambient air, let's say at about 45, 50 degrees from the air, push it down 200 to 300 feet. Or if you have a horizontal choice and a bigger place, then it can go only about 15, 20 feet and go about 300 to 400 feet running length. And there, the temperature in Islamabad is 23.2 degrees. So you expose it and let it stay there for a while till it reaches a temperature, let's say about 30 degrees or so. You bring it up, and then you have an auxiliary cooling system, which could be again very cheap. It could be evaporative coolers during summers running on the same solar system, solar power. And or you can have passive solar heaters which can run without any electricity connection during daytime, and they can bring the heat about one particular unit 8x4 can heat about 1,500 square feet in a freezing sunny day. So that kind of facility is available to us by nature. And then if somebody wants to put in a heat pump, again, can put in it, again, could stabilize another 4 to 5 degrees. Now, all of this we will be doing during the daytime. I would suggest that here we are thinking of putting 70 to 80% of energy, pass it through the RCC floors so that the energy is stored into the floors, and about 20 to 30% remaining is circulated inside the rooms. So this way it is running, it will be slow process. Maybe after a week, 10 days, your RCC slabs in the room will have the same temperature, which is 20 feet below, which is about 23, 24 degrees. So this, once you have done that at night, the system will shut down, and this very thermal energy that you have stored in the RCC slab will stabilize the temperature, as we heard the gentleman from Canada saying. And what you do at night is, as I've mentioned, that the same very energy which was stored in the body of the house, which is RCC floors, and maybe if you have brick walls and other things, so that will stabilize your temperature, and maybe a fan will do as far as the night is concerned. And this will be both during summers and during winters. So just to sum up this thing, the first is we need an insulated envelope around the building. Then we need to exploit the geothermal energy and use it as a primary source of heating and cooling, and it is powered by the solar energy. Supplementary cooling and heating could be used, which will be bridged about 5 to 6 degrees gap if there is any, and these could be multiple choices. And then we are using RCC floors, and the main idea here is to use the RCC thermal mass for the storage of the energy during daytime, and stabilize the temperature at night time. The building material I've mentioned will lower the structure weight by at least 50%, which will have an impact on all the frame that you're going to build the house and the construction material. Like I've given you the example of the high-rise building right here in Islamabad, where they were allowed to add 3 more floors, and that obviously was a very profitable decision from there. And obviously the construction cost and the labor cost would be, as I'm thinking, about 30% minimum down. So now just look at it. Now these 3 on the left, first the tags, insulated envelope, heating and cooling, and building material. This pertains to the passive house building. They're the key elements of the passive house standards. What we are doing is we are adding to the passive house standards the solar and energy to drive and use the geothermal energy, store the energy into our slabs, and then reduce the cost also. So I would say this is a design which is even better than the passive house design, which is considered to be one of the best design today, or the concept today. So we can leverage this for our advantage. And I was referring at green passive or whatever it is. And so there are obviously inbuilt inherent advantages of it. Once we have identified the domestic sector or the residential sector is the main cause for the energy crisis in Pakistan, so we are going right into that. There is an incentive for the house owners actually in the terms of a very nominal expense for very comfortable living. So I expect many people could be going into that. Corporate sector could see this as an opportunity also, because it has a local market and the national market attraction. And very important is that we will be, I think, having a very favorable impact on the environment, on the greenhouse gas, and also the heat island effect, which is taking place in Pakistan. And our bigger urban centers are about 5 to 6 degrees centigrade temperature has risen in the past about 10 years because of the excessive air conditioning and urbanization. And there is, I think, a role for academia, which hasn't been very, I would say, praiseworthy in this. There was no lead coming from the academia. I've been talking to many very renowned people in this sector, and hardly there was anyone who actually had an idea of these things. Corporate sector, of course, can see the opportunity and develop the capacity, and the state, I think, can offer stimulus because there is space for them. Instead of selling during summer peak hours energy or electricity at about loss of about 40 to 50 rupees per unit, they can, I think, subsidize maybe property tax or some of the other incentives so the people can come in. So this, I think, is a very good proposition in which there is everybody is a winner, and also the environment. So that was briefly the description of what my thoughts on these subjects are.
Clearly enlightening. So have you calculated about the cost? How much extra cost at the initial stage are we looking at for doing this ditch and then the other insulation stuff like that?
Yes, we have been looking. Obviously, the cost is very important consideration. And what I found is that, as I mentioned, the overall cost, I'm looking at about 25 to 30% lower compared to the normal traditional houses, because there'll be a very significant reduction in steel rebars, in cement, and the labor cost, and also bricks. If you're doing the partition as this high rise in Islamabad is doing with the panels, so that again can bring down the weight and everything else. Also, there'll be huge saving because you'll not be, I think, putting air conditioners, not more than 1 per floor, certainly, and also the heating appliances. So that also are a fair amount of investment in any building that you do it. And accordingly, these days, to offset the utility prices, we are putting in large solar panels on our top of the roof. So in this, where the energy consumption is 90% less, so if you were to put a 30 kilowatt solar system, you'll probably end up doing 5 kilowatts. So that again, so if you look at the saving, not only that in the construction cost, and then if you're living there with your family, and it is centrally heated and centrally air conditioned, you're paying under 5,000 rupees. So you're actually, the value is about more than 100,000 per month that you will be saving. So I think the cost is a very important thing, and that is coming in to this.
Already घर हैं, can we
Yeah.
install the same insulation and all these जो solar panel और नीचे से जो आता है, ये जो भी घर हैं, can you install it in those, और ये क्या उतना ही efficient होगा?
This is a very good question. In fact, we are working on the same, and the two options. Option one was where I mentioned the traditional construction material, both for the retrofitting of the old, the existing homes, and even if you are building new homes on the same material, you can actually make it. If you just do the insulation part of it and then drill one or two boreholes, you can have the geothermal energy. So I think there's a bigger scope here for commercial buildings where the electricity rates are very high, and this can be done. And daytime, obviously, the solar energy is also available in abundance. If we just put theoretically an insulated jacket around the house, because our base and foundation will not be planned, you cannot redesign that. So I think about 50 to 60% of the saving can be affected by retrofitting the existing homes or the buildings. So there are, if you put, let's say, a kind of a light frame around the building on the walls, and then you put insulation, which could be foam insulation, which could be PU insulation, and then you put, let's say, cladding board, cement board, simple. So you have placed about 2 to 3 inches of insulation. Ideal would be polyurea foam. If you do that, you will be achieving an insulation of something like 15 to 20 K. It's a light steel frame, which will be light aluminum frame or some very not very expensive. In fact, if you go around in Islamabad, you'll see many houses and the many buildings, they have this cladding and tiles on that. At least the front facade, almost 60-70% of the houses have. So this is exactly, we are putting already some kind of arrangement. We are just, what you're doing, we are pasting these tiles right on the face of the wall. So we are adding to we are not doing anything to help the insulation. So this very building, which I was talking, using the EPS panels, so they were about 2 weeks back in the process of putting the frame, and then they were put to do the cladding and the tiles there. So I asked them, if you just put 2-inch thick thermopore foam here, you'll be saving about 50 to 60% of energy, but I don't think they've done it. So, I mean, these are very easy solutions. And the other advantage is why the people aren't doing it, because they are not aware of it. Our universities, our engineers, our architects. I had a terrible problem with my architect who is building a house for my daughter. And he was not prepared. He is a good architect, very smart, very intelligent, and does a wonderful job. But on this side, energy conservation and consumption, he has least ideas and least prepared to alter.
Duty of the materials, other materials. Online भी देख लें, कोई सवाल पूछ रहा तो please याद रखें. And is there a duty on the materials? Are the materials imported? How many materials are domestically produced?
Sir, I think most of the materials are produced here, and some that they are not, they can also be produced here, and they are not very expensive actually investments to produce those materials. For example, the construction panels, I'm saying the EPS panels or some other sandwich panels are being manufactured about half a dozen or more big manufacturers in Pakistan. So those are the ones which are about 1/3 the weight of the normal traditional this thing, and they are comparable, but you save as far as the wall, brick wall and cement and plaster and these things concerned, they may be at par with them, certainly not more than that. But then the weight reduction which is there, it actually allows you to have a frame with lighter frame with less steel and the less concrete. So that there the saving would be there. It is pretty simple, but you need somebody who understands this thing. And luckily, we have a young person here in Islamabad who was Georgia Tech graduate here, and he is doing some of the projects and also got some national award also. And he is also helping me. Incidentally, I'm also planning to start a house in which this very concept will be applied, inshallah. So we do have the basic things, but also it's not very difficult to get hold of the people. Like one of the Zoom meeting that we had, and Dr. Nadeem was part of it, and we actually talked to a Pakistani doctor, PhD in geothermal, who is in Sweden, and he was very excited, and he was talking of the potential and the possibilities in Pakistan. We have certainly, I mean, this is doable, perfectly doable, and it should be done. And I'm really surprised why we are not doing it, why we are not looking at it. No, what I know, you're not actually doing it. You're just doing 2 boreholes or 3 boreholes, depending on the size of the building. If you don't have a large lawn and everything else, and there you are just pushing the ambient air into it and getting it, some filters and some blowers. There's no permission needed for this thing. We are actually now in the process of calculating these things, because we have to, it has to be a kind of a simulation kind of exercise and a thing done on the software, because the kind of material that you are using and the energy required to store and to cool it down. So that in turn translates into the volume of the air and the temperature of the air which needs to be inducted into it. And then you have to go reverse into the boreholes, how deep they have to be, what is the area, and how long they have to be in circulation, and what differential will be making. If we are making about 15 plus degrees ambient and the temperature that we get geothermal energy, it is perfectly doable. And this all is actually one-time expenditure of 2 bores. Obviously, I think would be how much? 2 air conditioners cost? I think no more than that. So it's not really a big ask there. It's happening in quite a few countries. India is doing a lot in the geothermal. Of course, I mentioned about the glass fiber reinforced gypsum panels. They are doing it. Rest in Europe, they are doing it. But in Europe, obviously, they have to go very deep. The government in the US is subsidizing by 75% of the cost. And they're encouraging the people to come with it. And here in Pakistan, we actually have this. They have to rely on the more expensive and more difficult, complicated techniques, because drilling 2,000, 3,000 feet deep, lifting the water, circulating it. And then what they are also trying to do is they have to, Dr. Saqib in the Zoom meeting said, is that you can, all the heat that you are generating in the summers, you can actually sink it back into the earth batteries or sand battery you're seeing. But in Pakistan, I told him we don't need, because we have 12 feet, 15 feet down ideal temperature. So why invest into that? So we actually have one of the most ideal conditions in the entire world to actually do this thing and go beyond the passive standards for using this. Yes, sir, I can hear you.
बहुत शुक्रिया, आपने बड़ा अच्छा ये इंट्रोड्यूस किया नई टेक्नोलॉजीज. इसमें जो मेरा सवाल से ज्यादा थोड़े से 1-2 कमेंट्स हैं, और वो ये है कि हमने देखा है कि जब भी कोई नई चीज इंट्रोड्यूस होती है, खासकर पाकिस्तानी सोसाइटी में, जनरली सोसाइटीज का ये होता है कि दे रेजिस्ट, वो नक्शे कोहन पे अड़ना और आईने नौ से डरना, ये नॉर्मल हमारा तरीका है. लेकिन इसमें कुछ ऐसी प्रॉब्लम्स भी हैं जिनका मैं जिक्र करता हूँ. मेरा ख्याल जब तक उनको आप ओवरकम नहीं करेंगे, इसको इंट्रोड्यूस करना आसान नहीं होगा. और सबसे पहले इसकी लॉजिस्टिक्स, जिसका जिक्र हुआ है कि इसकी अवेलेबिलिटी, और दूसरा इसकी एक्सपर्टीज, कि ये लगाने वाले लोग किधर से मिलेंगे. मतलब मैं फॉर एग्जांपल मैं कहता हूँ हाँ जी आज लगा दे, अभी आपकी कंपनी तो है, हमें तो पता नहीं है कि मार्केट में कोई और भी ये काम करता है या नहीं. आप इससे अंदाजा लगा लें कि ये जो हमारे सोलर सिस्टम्स हैं, इसको जितना, ये हालांकि सिंपल चीज है, इसको पाकिस्तान में इंट्रोड्यूस करने में 15 साल लगे हैं कम से कम. तो आई वुड सजेस्ट कि कोई गवर्नमेंट के साथ मिलकर ऐसा इंतजाम किया जाए कि पहले तो जो बड़ी कंपनीज हैं वो इसको अडॉप्ट करें, गवर्नमेंट खुद इसको अडॉप्ट करे, और फिर ये एक नमूने के तौर पे लोगों के सामने पेश किया जाए. क्योंकि हमारे लोगों का ये ट्रेंड है कि हम घर बनाते हैं अपनी नस्लों के लिए, कि जी इतना मजबूत होना चाहिए जी, एनू तो थोड़ा नाल तोड़ो तो नहीं टूटे. तो इस किस्म का जब तक आपका एटीट्यूड है, तो ये सारे मामला जो इंट्रोड्यूस नई टेक्नोलॉजीज कर रहे हैं बहुत मुश्किल है हमारे माशरे में. तो जो माशरती ट्रेंड्स हैं कि किस तरीके से ईंटों और सीमेंट से निकलना है और कैसे लोगों के ज़हनों में ये चीज डालनी है, तो इसका जो मार्केटिंग साइड है, इसकी जो लॉजिस्टिक साइड है, आई थिंक दैट इज वेरी इंपॉर्टेंट. सिर्फ इसका मौजूद होना या इस इल्म का मौजूद होना या थोड़ी सी क्वांटिटी में चीजों का मौजूद होना, मेरा ख्याल इससे ये चीज इंट्रोड्यूस नहीं हो पाएगी. बहुत शुक्रिया.
Thank you very much. I think nobody will disagree that these are the challenges. The technology is tested, tried everywhere in the world, many countries in the world. And about the capacity you're talking, materials obviously are available even in Pakistan. I don't see anything which is not available. Expertise, definitely we don't have. I was lucky to have this young fellow who is in Islamabad. So he is a big source of strength for me. We also have Dr. Naim Saqib, who is a professor in Sweden. And he's very willing to develop some collaboration with the local universities and the people here. And he is one of the world-renowned authority on this thing. And he is very willing to come here and help us out in any way. And he has already, I had few sessions with him, and he is very excited to help us out in this. Also, I have another fellow, again, a Pakistani, who is in Chicago. And he was the one who actually did geothermal heating at the new Chicago airport terminal about 4 to 5 years, which is doing very well. And this fellow, about 3 months back, actually built a house for somebody and achieved 99% energy efficiency. And he is very willing to come here with his team and help us out. So we do have to leverage people. Obviously, in Pakistan, we have some difficulty, but I am looking at building few houses with the support of these people and people like you, obviously. And hopefully, I think that should be a good start because of the advantages that we have and the need that we have. Energy, in any case, is a very big crisis, and this very thing which has incentive both for the homeowners to actually go for this thing and have a comfortable living at lower cost and lower energy bills, and the government, which obviously is in very difficult situation because of the energy dependence on the imported fuels. So I see there is a big need and there is opportunity, and we should be able to do it. It will not be easy, but nevertheless, it's possible. The first step I have is to actually put a proof of concept on ground. And from there onwards, I hope that we should be able to move forward.
The regulation part, knowing CDA, they'll be wanting to interfere in it. So how do you plan to work around that? And the second is the bricks you showed us, the interlocking ones. They have something similar they're using now with those are concrete bricks they've made with the air pocket in between. So how is it different from that one?
Regulations, I think I don't see really a problem in a regulation, because if you are building a house which is on a frame structure and the walls are non-load bearing, and they have we have the technology that it can be made even stronger than the concrete with some coatings and some other solutions. So it's not really a technology issue. It's obviously familiarity. And I am actually going to meet the head of the design in Barrier Town because I want to do some of the things. So he has agreed to support me because he has the experience of this thing. So hopefully, I think there'll be some problems which always are there in the first venture of this time. But it's a tested technology. I plan to get the endorsement and approvals and the planning from my friends abroad. So with very impressive references, and hopefully the people will see that this is possible. And about you mentioned something about bricks. Yes, the bricks and blocks, and what you are mentioning are hollow blocks which are being used. In fact, little CLC blocks and all those things are coming up in market now, and they are improvement over the bricks, obviously, also from the environment point of view and from construction point of view, both. But I want that instead of going from one step to another step, we should leapfrog to the construction panels, the 10 feet by 4 feet board and panels, which is fixed and then interlocked with the next one, and you move from there. So that is the direction in which I would like to go, instead of moving incrementally from the clay, these kiln bricks to other compressed earth break, or the interlocking bricks, or interlocking blocks, or hollow blocks, or CLC blocks. We should be moving towards the panels, and that is the idea. It will be more durable, it will be sturdier, it will be having better impact resistance and fireproof, and of course light in material, the way better than what we have now. Thank you, sir.
There you go, ladies and gentlemen. Thank you, Brigadier Saab. Here's a man without any pay, without any job, just passion. has researched something that we have not done. We should all be a little bit humbled by that. And we should accept that this age discrimination and this triumph of the youth without any achievements has to end. The world is about achievements. The world is not about age or anything. Or the world is not about having a government job and going to sleep and pretending to do things. Like some people just came and pretended that they attended the webinar, sat for 5 minutes and left just to show that they were here. This is how we operate, Brigadier Sahab. We operate like this. We try and show that we were here, mark our presence, then we go and have parathas and omelette. Thank you, folks. All the best.
Thank you very much.
Thank you, Brigadier Sahab. Big thanks
Thank
to
you
you.
very much.